Hello friends, welcome to Damu Education. If you not yet subscribed, please subscribe and click the bell icon. So in this model, we are going to discuss our ninth question. They are given that ABCD is a square. So whatever given conditions, write it first. So ABCD is a square. Then EFGH, these are the midpoints of. So EFGH are the midpoints of AB and BC, CD, and here AB, BC, CD, and CA. So sorry, that is DA, and such that AE will be equal to here. AE will be equal to BF. So they are given that AE will be equal to BF, that will be equal to CG, and that will be equal to DH. So these are the AE will be equal to EF, then CG, then DH. These are the equal, and A is the midpoint, means AE will be equal to EB. So we have to show that what is the required to prove. So RTP is, what is that? So RTP is EFGH is the square. So we need to show this EFGH is a square. So for that, what we have to do here is, first we are going to consider the sides, then we have to move on the angles. So actually here the sides will be equal to, we should know what is the midpoint theorem of the triangle. So what is that we have to know before itself. So XYZ, let's take this is the XYZ triangle, then take midpoint of any one side. If you draw one midline, that is draw this one, let's take this is P and Q. So here what you can take it here is, this is the PQ is parallel to XY, and PQ is the line joining from the midpoints of the sides. Then what you can write it here is, PQ will be equal to half of the XY. So PQ, this is the line which will be off of the XY, it will be of the length of the XY, that is like that. So here same as it is here, what we will take it here is, let's take here, let's consider the EF. So from EF we are going to start. So AC and BD are diagonals of square. So here let's consider EF is midpoints. So let's consider that this is the triangle. So if you take this triangle ACB, so from triangle ACB, what you can write, EF is parallel to AC. EF is parallel to AC, that to join from midpoint. So ACB's triangle is looking like this. So this is the ACB triangle, and EF is this like this. So EF, this is AC. B. So this is like this we are taken. So EF is parallel to AC. Then what you can write it here is, so EF length will be equal to half of the AC. Let's take this is first one, equation 1. And diagonals AC will be equal to BD. So that also we should know. So diagonals AC will be equal to BD. Our next condition. So triangle, let's take EF is over, then FG. So triangle CDB. So CDB, then what is the next condition here is, GF is parallel to DB. So GF is parallel to DB, then what you can take it here is, GF will be equal to half of the DB or BD, anything you can take. So let's take this is equation 2. Our next condition, so triangle, let's consider of triangle ACD. So triangle ACD, then what you can take it here is GH. So this side is parallel to AC. This side is parallel to AC. That means GH will be equal to half of the AC. Let's take this is equation 3. Then equation 4. Let's consider ABD. So ABD triangle. So ABD triangle, what is that? EH is parallel to BD. Then what you can take it here is, EH is equal to half of the BD. So let's take this is equation 4. Then finally what you can write it here. So we can write one case here. What is that condition here is all the sides and diagonals are equal. So if it is a diagonal, DB and AC are diagonally equal, then EF will be equal to, and GF will be equal to, GH will be equal to, EH will be equal to half of the BD, that will be equal to half of the AC. So why? Because since here we are taken, so diagonals are equal, so AC will be equal to BD. So all sides are equal, and one more condition we have to move here. We have to check for the angles. So here these sides, so all sides are equal. So all sides are equal in this. All sides are equal. Then we have to check it in the square of this one. So we have to check it in the what is that? Angles. So let's go and check. So here diagonals are making 90 degrees. So here also making 90 degrees. So let's consider these points of. So let's going to consider, or you can consider any points. So here 90 degrees. Let's take this as the point of X and Y. So let's consider the midpoints X and Y are midpoints or any points of, let's take midpoints of, so what is that? EH and EF. EH and EF. Then it is making, so EXOY is a parallelogram. Is a parallelogram. Then what you can write it? So in parallelogram, opposite sides are equal and angles also equal. So here they are parallel. This is XO is parallel to EY and OY is parallel to XE, and angle O will be equal to angle E here. So angle O will be equal to E, that is 90 degrees. Why? Because opposite angles are equal in the parallelogram. So opposite angles are equal in parallelogram XOYE. Anything you can take like that. So if you do continuously like this for this here, so diagonals are making 90 degrees. Don't get confused. So how we got it here is the diagonals AC are perpendicular to BD and they are making at center 90 degrees at every corner. So for that opposite angles also here. So it's making 90 degree here and here also 90 degrees and here also 90 degrees. For this all opposite angles are 90 degrees if you take all the points like this. So similarly what you can write? So all the corners have right angles. All the corners have right angles in the shape. What is that? Shape EFGH. So that is the quadrilateral. You can take quadrilateral like that. Finally, therefore, we are shown that sides are equal and angles also. Here 90 degree, here 90 degree, here 90 degree, here 90 degree. So we are shown like that. So based on therefore, what you can write? EFGH is a square. So EFGH is the square based on this condition. Thanks for watching. Please subscribe.